Note: this video is the abridged guide to making luminol and glosses over details to present an overview of the process in a shorter, more concise form. Please go to the complete guide if you want all the details. Greetings, fellow nerds. So in this video we're going to make luminol. It's pretty easy to make using lab chemicals like 3-nitrophthalic acid, hydrazine, and sodium dithionite. But as an added challenge, we're not going to start there. Instead, we're going to make luminol entirely from chemicals that can be found domestically in hardware stores, supermarkets, and pharmacies. For safety reasons, I'm still going to use my lab equipment though. To get to luminol, we're going to start with vinyl gloves made from polyvinyl chloride. These contain diethylhexyl phthalate. To extract it, we cut it up and boil it with some rubbing alcohol. After a quick filtration, we now have a solution of diethylhexyl phthalate in isopropanol. We now convert it to phthalic acid by first adding water and sodium hydroxide-based drain cleaners. The mixture is boiled for an hour or two and then allowed to cool. It'll separate into two layers. The disodium phthalate will be in the bottom aqueous layer, and all the alcohols will be on the top. Separating out just the bottom layer, we then add some hydrochloric acid. This converts the disodium phthalate into phthalic acid and sodium chloride salt. The phthalic acid precipitates out after several hours. Now we convert to phthalic anhydride and purify it by heating it on the hot plate to 300 Celsius. The phthalic anhydride boils and then solidifies against this flask of cold water. Periodically, we scoop it out for collection. Now we have pure phthalic anhydride. To nitrate it, we mix it with sulfuric acid-based drain cleaner along with sodium nitrate that we made in a previous video from instant cold packs and sodium hydroxide-based drain cleaner. Then we carefully heat the mixture for 2 hours. Afterward, we let it cool and dissolve the resulting mixture of products into water. Leaving it overnight, the 3-nitrophthalic acid precipitates out and we separate that by filtration. Now we condense it with hydrazine, but first we need to make that from methyl ethyl ketone, ammonia, bleach, and sulfuric acid as we showed in a previous video. We also need to get sodium acetate trihydrate that we made in another video. Once we have our ingredients, we mix together the 3-nitrophthalic acid, the hydrazine sulfate, and the sodium acetate trihydrate along with a little water. We boil the mixture first to dissolve everything, and then further to dry it. For the second stage of the reaction, we get brake fluid containing polyethylene glycol that has a boiling point greater than 230 Celsius. Adding that to the mixture, we can now heat it much higher and drive the reaction forward. We're almost done, and now we need to convert that nitro group into an amine. To do that, we first dissolve everything in sodium hydroxide and then add sodium metabisulfite. This is sold as a disinfectant for home brewing and as a stump remover. Now we get aluminum foil and jam it into the beaker, holding it down with a flask while it reacts. This finally produces luminol. We're not done yet. The luminol is still mixed with this large amount of byproducts and contaminants. To purify, we first filter off all the excess aluminum and aluminum oxides. Then we prepare a mixture of the swimming pool chemical sodium bisulfate along with water and acetone. Adding everything together, the luminol dissolves in the liquid while most of the waste precipitate out. The luminol solution is carefully decanted off, and then allowed to dry for a few days. The resulting cake is broken up and some water is added to dissolve any remaining salts, but not the luminol. The slurry is filtered and allowed to dry. To test it, we can dissolve a tiny amount in water and first check for fluorescence. Luminol exhibits a very strong blue fluorescence in water. Then for the ultimate test, we add bleach to it with the lights off. That flash of light proves the presence and activity of luminol. Another test is to mix the luminol with the methylsulfonylmethane muscle rub and sodium hydroxide. This gives a much longer lasting green glow. So there we have it. It took a lot of work, but we made luminol entirely using domestically available chemicals. Sure, it costs thousands of times more than buying it directly, but our objective here is to explore the science. Thanks for watching the abridged guide.